Alright everybody, hello and welcome to the wonderful world of model making. So right here we've got my materials I used. I used the big marshmallows, small marshmallows, and the nice little rectangular marshmallows that they make for s'mores. Skewers, I've also got some toothpicks and straws in mine, and also used a marker and some wax paper. So pretty relative materials that don't cost a whole lot and are pretty accessible wherever you want to go and get them. Real quick, whenever I was researching which model I wanted to do, I couldn't decide if I wanted to do like a 3D model or if I wanted to try to use a computer simulation or drawings or what. But really, the model or the research that I found, just kind of talks about how different different types of models are good. I'm not very technologically advanced, so I really wanted to stay away from that. And so I just chose to make these models right here. And with these models, I wanted to cover the things that we were asked to cover with the NGSS, being the 4 components, the 3 relationships, and the 7 connections. As you can see, there's plenty of models here, and I'm pretty sure I've been able to capture all of that for you. So let's just get to it. All right. The first model, or model that I made was the H2O molecule. And this molecule, the students can see the individual atoms as far as the hydrogen atom, the 2 oxygen atoms, and then the whole molecule of the water molecule as its whole. The next one is sodium chloride. Look here. Now, tell me that's not a beauty. 3-dimensional. We did have 3 layers, but that's one of the weaknesses of my model was that marshmallows really don't hold up so great. So we kept falling over this and that. So we've got a few of them that are labeled. The rest could be for this purpose. And we want to show this one because it shows the students that repeating the molecules and repeating atoms can form extended structures. And it also shows that, it doesn't matter if you've got 1, 2, or in this case, 13 different atoms that they can all combine to form structures. The next one we go to is the sugar. The sugar is kind of like, it's more complex, kind of just like the sodium chloride. This one shows that the atoms of different kinds can attract to make extended structures, and that's what this one is demonstrating with the carbon, the hydrogen, the oxygen, and then over here they'll have the little hydrogens that are hanging off. The next one we're going to go to is the CO2. And the reason that we did the CO2 is the CO2 don't really attract. This shows different molecules that can combine without being attracted to each other. And the reason I've got the 2 toothpicks in there is to show the bond, because unlike over here where we've got positives and negatives that are attracting with the charges, here we don't have that, and we've just got the bonds that are connecting the oxygen to the carbon. Next we're going to the helium. Here I've got a broken down version of it where I've got the protons, neutrons, and electrons to show you that we all know that positives or opposites attract, and then 2 positives and 2 negatives repel each other. And so then we've got the other helium here that's kind of without a partner over here, not showing. If we wanted to show it connect, we'd have it here. We've got it here to show that they don't necessarily attract each other, so they can connect, but they don't have to. And then the last one is O2. Actually, it's not the last one, but O2, kind of like CO2, but this one's just showing that molecules that are not attracted of the same molecule can combine. All right. And then last but not least on the model list, we've got H2O, and it's in the solid form. So they're all tightly compacted together, and which we know, solid H2O is ice. And then here we've got the liquid. All right, they're all spread out into the container. They're moving freely, being able to go and bump into each other. So that was to show that at a macro level, the students could see the difference in the molecules and the atoms. Some strengths about my models is I think they really do a good job of providing that question starting ability that we want to use with models and discussions, and talk about how these are different and the same. And I think that they do a really good job in capturing that. I think some of these are really good models that you could use in your classroom that could stay a while. You wouldn't want to eat them after a while. But then again, that's also a weakness, is like your three-dimensional structure here is not that great, because these things tend not to hold up very long whenever they're stacked on top of one another. So that'd be a weakness. Another weakness would be the size differential in some of them. This one you can kind of see, the differentiation in size, and we don't want students to think all molecules or all atoms are the same size, because we know that to be incorrect. And so that's another weakness of mine. And really, overall, I mean, I think they do a pretty good job of capturing the idea. And another strength that I mentioned earlier is they're pretty cost efficient. So one bag of marshmallows is $1. I think I spent $4, getting this whole thing together, maybe $5. So that's definitely a strength. And I do believe that's about it. If you guys have any suggestions about how I can make my models better, I would appreciate your help, and I'll try to provide feedback on your videos as well. Thank you for your time.